Okay, so this is my first attempt, successful attempt for the RRT algorithm. As you can see, the starting point is over here, and after many iterations, the agent avoids this particular obstacle and works around it to go over here. So this is my final point, and yeah. Okay, and so created this script using Python. Um, this is a simple script, just these many lines of codes. So what I did was I outputted the C++ code into three files: the obstacles, vertices, and edges. So obstacles are all of these. Uh, Vertices are the lines. No, edges are the lines. Vertices are all the dots. So I just outputted them and read them using a Python file, and this was enough for the visualization. As you can see, the algorithm works for this kind of obstacle as well. So here's one obstacle and here's another tiny obstacle in the bottom. So I'm going to show live coding changing this. So let me just move the bottom obstacle a little higher. How much higher do I want it to be? Okay, this much higher. Close this, recompile everything again. Oh no, I made it lower. But still, you can see that it works. It's recompiling. Not 390. Okay. Let's see what this does. So yeah, you can see because the area is really narrower, the agent mainly gets stuck in this area, and only like after a while it finds the pathway through this narrow pathway and reaches this goal. So yeah, this is very interesting. Let me change it once more. What I want this time is let's do a different kind of obstacle. Let's do something else. 260. Let's do 290. And this time I want to let's see what kind of what the agent does now. Oh, yeah, but I want it to this to be narrower. Okay. 220 and 260, and I want this to be even higher. Say 220 again. Okay, so yeah, again, this is very interesting. So the agent gets stuck over here, barely finds a pathway through this, and reaches this part. So I finally got my simulation to work. So this is my gold state. Anywhere below this box is going to be the gold state. So let's start the simulation. Okay, and I have a Python script to show the map as well. So this is going to be the path the bot is going to follow. As you can see, it's going from node to node. It's gonna go here, 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 here. So as you can see, the robot is following the exact path of the algorithm. The boxes are a little bigger over here because just to consider some more leeway for the robot, because this is a practical a maneuver tactic I implemented or something like that. Just so the robot doesn't accidentally unintentionally collide with objects. So as you can see, the robot is going from node to node. Um, here. Now here. Okay, it's gonna go sideways now. So let's fast forward, I think. So, documenting my struggles. So this is a particular issue I'm getting right now. So it's kind of interesting as well. So let me start the simulation and see what I'm trying to say. So as you can see, the occupancy map, it's developing an occupancy map, but the problem I'm struggling with is trying to figure out how frequently I want the paths to change, and finding a right balance of some sort, and how often I want the trajectory, the path to change as well after the updating the occupancy map. So as you can see, the occupancy map is getting crisper and crisper for the robot, but because of the incorrect implementation, right now it's not going anywhere. It's not reaching anywhere. Just changing its path over and over again. And yeah, I'm going to fix that, but I thought it was an issue worth mentioning. So I think I solved that issue. Um, this is my previous simulation, as you can see. It looks pretty well. Let me restart it and see what it does this time. So this is the starting simulation. It's pretty bad. So what I did in this, what I tried in this time was to update the occupancy map in a like much later time interval, and I also did something. I immediately update an occupancy map if like an obstacle is right ahead. So like to avoid collision, like if the epoch robot detects that it's gonna collide something, and if it goes in its current trajectory, I'm gonna update the occupancy map and just update the graph as well, so that it's gonna play the RRT algorithm on the graph again to find a better path than the previous time. And so yeah, as you can see, it's already on its way to, it's much better. So let's see, after I think, so this time after it updates its occupancy map, it surely it puts more of the world information. Uh, so yeah. So the primary improvement from the last time was to integrate the distance as well, and an obstacle, like update the occupancy map if collision is predicted. So let me fast forward everything. Yep. Okay. So far so good. So it just it reaches the goal. It just keeps on speeding after it reaches just below this box. So two different ways to traverse the algorithm. In the previous one, the environment was fully observable, and this time with only using the sensors, the agent was able to figure out this much of the information. Okay, now that I know for sure that the robot is working, I just want to stress this stuff out. So as you can see, the robot over here, it's kind of in a difficult position. I'm not sure if it's ever going to pass through this obstacle, but I just wanted to document this. Okay, so here is the occupancy map. It's come up with by far. Mm, it thinks that it can go through the wall because it doesn't see the wall behind because the light, this part blocks the light over here. So yeah, it thinks that it can go in this way. Obviously mistaken, but understandable. Mm-hmm. Yep, it knows that now there are walls over here. There are obstacles. It doesn't need to necessarily be walls. As long as the light gets reflected, anything works over here. Just easier to make the walls as environments. Now it finds out that it was mistaken, and oh no, I'm thinking it's gonna try to go through this tiny hole because it doesn't know that it's fat. It's not gonna fit uh, because these are edge cases. Yep. Yep. All right. It found out that yeah it worked. So now it finds that it needs to go around, not through that tiny hole. Okay. Okay. So yeah, as expected, it got a little stuck over here. But the good thing is, the robot actually made it out and found a new pathway. So yep, again, it updated the occupancy map, so it's gonna work now. Yep.